So general equation of an ellipse. Just going to continue on from our circle notes. We're moving on to ellipses. Kind of similar to that of a circle, right? You see the x minus h squared and y minus k squared is in there, right? That's representing the center of the ellipse. But we've divided through by something to get 1 over here on the other side. And so you'll see an a squared and a b squared underneath. And we're going to let a represent what's known as the length of the semi-major axis. So if a is the length of the semi-major axis, at least when it's turned this way, okay. Let's go ahead and label it here. It doesn't really matter what you call A and B on the ellipse so much. You may have remembered that from last year. But we're going to call A the length of the semi-major axis. So this right here is A, and that's A is equal to the length of semi-major axis. And then B right here is equal to the length of the semi-minor axis. So semi means half, right? And major is the longer of the two on the ellipse here. And then the minor is the shorter of the two. Okay? So A and B could switch if that ellipse were turned so that it's longer vertically. Okay, and then H and K represent the center. And you should also notice that it is set equal to 1. As a matter of fact, a circle is a special case of an ellipse, right? That's where A and B, the semi-major, length of the semi-major and semi-minor axes, are the same. They're equal to the radius. Okay, the center is HK. And it's not in the same form, but you could put it in this form by dividing through by r squared. You'd have an r squared here and here and a 1 here for the circle. And so they're very closely related. The construction of an ellipse. Ellipse construction. If we were to take, well, here's what it means to be an ellipse. An ellipse is where the sum of the distances from from one focus. So you might have a focus, call this focus 1, another focus here, focus 2. But the sum of the distance from one focus, that's focus 2, to a point on the ellipse, and then from the point on the ellipse to the other focus is always the same. So if you were to picture taking a string here maybe and tightening that string, pulling it, stretching it tight here, as you rotate this dot around the ellipse, that string length will remain constant. So an ellipse is where the sum of the distances from focus 1 to a point on the ellipse to focus 2 remains the same. That's the geometric definition. And my applet here no longer is working, so I can't show you my applet on it, but I'll have to find another one and show it to you another time. So, have we got the formula down? You know what each part of the formula is here? HK is the center. A is the length of half the length of the longer axis, and B is half the length of the shorter axis. Well, we're going to do some mathematical modeling with the ellipse, which will be a little bit of something new from what you did last year. The idea being, if you can find the equation of an ellipse and plug in, say, the x-coordinate of some point on the ellipse, you could find the y-coordinate or vice versa. All right, it says find the ellipse equation, and we're given foci on the x-axis. The fact that the foci are on the x-axis tells us that that is the major axis. So if I draw a picture here, it says I have x-intercepts of 4 and negative 4. By the way, these points here and here are called vertices. That's a vertex. This is another vertex. So the vertices or x-intercepts are at 4 and negative 4. Y-intercepts of positive 3 and negative 3. The foci, that's plural for focus, is somewhere on the x-axis. It would be one would be between 0 and 4, and another one between 0 and negative 4. So there's a sketch of it. So here we have A from here to here, and that's equal to 4. And B is from here to here, and that's equal to 3. And then I have a center. So the center H comma K is the origin. So plug everything in here. I have x minus 0 squared over 4 squared plus y minus 0 squared over 3 squared equals 1. If I clean that up, I end up with x squared over 16 plus y squared over 9 equals 1. And that's the equation of my ellipse. That you probably did last year. Take a picture of an ellipse, find the equation of it. Did you talk about the geometric construction of it last year? Okay, so it says find the equation of an ellipse with center at 3, negative 1. So let me draw a picture of this here. So center at 3, negative 1. So there's my center. And endpoints of the major and minor axes at 1, negative 1. So at 1, negative 1, we have a point. So go ahead and draw this with me. Another one at 3, comma 4. So 3, comma 4. And then another point at 5, negative 1. And another point at 3, negative 6. So can you tell at this point which is the major axis, or what is it parallel to? Let me draw it in too. Major is going to be the longer of the two axes. I switched on it. So what that means is that I'm going to have A underneath the y term. And it actually doesn't matter which is A or B. You're just going to have the bigger number underneath the y term. Okay? So it'll look like this. We have x minus 3 squared over plus y, using the same principle we did with the circles. This will be y plus 1 squared equals 1. Now let's figure out what goes underneath what. This time the bigger of the two axes is parallel to the y-axis. We'll call this distance from here to here. That is a distance of 5, so that's a 5, and then this guy from here to here, 2. So we'll have a 2 squared or 4 underneath the x, and a 5 squared or 25 underneath the y. So it's changed what the semi-major axis is. So the semi-major axis is 5. It's parallel to the y-axis. Okay. Also notice the center is not the origin this time. All right. So let's go in one direction. Same thing we did with the circle. Let's go the other direction. Can you tell me what the center is on 5A?
Origin.
Center is the origin. I'm going to put a dot in the origin. Can you tell me how far to go out in the x direction? A squared equals 9, so A equals 3. Yep. So in the x direction, go out 3 in each direction. And then here, if b squared equals 4, then b equals 2. So I'd go 2 in the y direction, and then draw my ellipse. Okay. So we're okay on that one? How to find the lengths? You can see it. So the a squared is what's on the bottom of the x. That's the major axis in this one. It's longer horizontally. And then the b squared is equal to 4, so b is 2. All right, before we graph the second one, what needs to happen to it? What do we need to do? Yeah, divide by 20. So when I divide by 20, I have x squared over 1 plus y squared over 10 equals 1. Now it's in our standard form. Still got an origin as the center. But this one is longer on the y. It's only going out 1 in each direction on the x. Okay. In other words, in this case, b squared is equal to 1, so b equals 1. And a squared is equal to 10, so a equals square root of 10. So square root of 10 as an estimate would be what? Just over 3. Yep, about 3-ish. So let's go up about 3, and we'll put a dot there, just past it maybe. And then draw in our football here, ready to be kicked through the uprights. So there's our ellipse running vertically. So first thing you had to do is divide through by 20 to set this equal to 1, get it in standard form. Then we can tell that b, the length of the semi-minor axis, is 1. And then the length of the semi-major axis is square root of 10. All right. Final one. It's not centered at the origin. It's centered at an h comma k equal to 2 comma negative 4. So going over 2 and down to negative 4, place a dot there. And then this one's going to be longer horizontally. You can see that a squared is 25, so a is 5. You're going to go 5 in each direction from the center. Place a dot. Place a dot there. And then here we have b squared equals 16, so b equals 4. And that's the graph of my ellipse. So you should be able to graph them from the equation, or given the graph, write the equation. Let's just look at a couple of mathematical problems. All right, here we go. So it says a racetrack is in the shape of an ellipse. So we're going to use an elliptical equation to model it, okay? It says it's 100 feet long and 50 feet wide. So this is 100, meaning that the semi-major axis is going to be half of that, or 50. So 50 and 50. This is 50 feet wide, so this is 25. and 25. Okay? We get to decide, guys, where we're going to place this track on our graphing grid. So we want to probably place it at the origin, center of the origin, right? Might as well, since we get to decide. So our equation is going to look like this. It's x squared over 50 squared plus y squared over 25 squared equals 1. Okay, so you see where I came up with the equation? Centered at the origin. Centered at the origin. We're just using x minus 0 squared plus y minus 0 squared. Go ahead and square the bottom of each term. So it's 25. So there's our general form for that elliptical equation. Now it says, what is the width of the track 10 feet from a vertex? So remember, a vertex is out here, or it could be over here, but 10 feet out from the vertex. So I'm coming back 10 feet here. And the question is, what is the width of the track between these two dots? So I've got to find y and then double it. What's the width of the track coming back 10 feet from a vertex? So, let me ask you this. What is my x-coordinate right here? Well, here's the origin. In this case, it would be negative 40. What if I went over here and did the same thing?
40.
Okay. And this would be 40. So it's your choice. Is it going to matter if I do negative 40 or 40? It's not going to make any difference, right? So if x is 40, we're going to plug it in. And then solve for y. Oops, I don't have a lot of room here. So 40 squared, we're plugging in 40. Do you guys see why I plugged in 40? That's how far out I would be from the origin at a point that's 10 feet in from the vertex. 50 minus 10 is 40. And once again, it doesn't matter if I plugged in negative 40 or positive 40 because of the squaring that's going on. Now we have some arithmetic with fractions to do. So it's 1600 over 2500 plus y squared over 625 equals 1. I'm going to subtract. Well, let's lop off some zeros here. How about if I subtract 16 over 25 from each side? So it's y squared over 625 equals 1 minus 16 over 25. And we'll draw an arrow here. 1 minus 16 over 25. What's 1 whole minus 16 25ths going to equal? 9 25ths, yeah. What would you do to handle something like this? Cross multiply, sure. What's 9 times 625? I need some help with that. And then divide by 25.
That's a
5,625, okay, and then divide it by 25.
225.
Oh, perfect. So what does y equal? Perfect square, yeah, it's 15. So, what does that tell me? If y is 15 right here, y is 15 here, the width of track at that point is the point 10 feet in from the vertex, is 30 feet. So the width of the track right here is 30 feet. So this elliptical equation, we can use it to find a y coordinate of any point along this ellipse, okay? So you're going to write a mathematical model. In this section, just an ellipse equation. And then plug in what you do know, either x or y. It could be either one, you know, solve for the other. A pitch. It's a slope. A rise of 5 and a run of 4. It says we have a radius. So you're installing a fireplace that has a flue with a radius of 4 inches. So that means all the way across it's 8. So here's the thing. I got to translate this into units that are kind of correspond to the entire diameter of the flue. So if my rise, every time I go up 5 inches, I go over 4 inches. How many rises will I have to go with an entire diameter of this flue? 10 of them, yeah. So I'm going to have a triangle that looks like this. I'm going to go 8 and 10. So this is 8 across, right? If that radius is 4. And that's going to bring me 10 up if I have to stick with a slope of 5/4. Okay, if I have to double my run to 8, then my rise has to double to 10. And so what I'm finding here is this distance right here, call it x, or c, or whatever. That's elliptical shape. We don't even need the equation of ellipse to find it. It says, what are the dimensions of the hole? So the yeah, so we have x equals square root of 8 squared plus 10 squared. So x equals, what is it? Square root of 164. Okay, what number do you get? Okay, so x is about 12.8 inches. So if you tell somebody to measure out square root of 164 inches, they'll look at you funny. So what are the dimensions of the hole? They are so you're cutting this hole. Here's the roof surface is what's in blue here. So you're cutting this the roof surface. So the dimensions of the hole are 12.8 inches by what? Well, I don't think 4. It'd be 4 from like here out. So it's going to have to be 8.
Oh, yeah.
So by 8 inches. So you can measure a radius. It's kind of hard to picture because it's a two-dimensional picture, but right out here would be a 4. So from here to here would also be a 4. It's kind of weird to give dimensions of a ellipse in that way, but the dimensions of the hole, you're going to have an ellipse that is 8 inches wide, has a minor axis of 8 inches, and a major axis of 12.8. So this is the major axis, and this is the minor axis. And then your elliptical hole will accommodate that flue that's hitting it at an angle, coming on through the roof at an angle. Then you build a template, and then you've got it set for every 5/4 roof that you run into. Just put the template on there, cut. Somebody had to do the math to figure that out. The first one. The guys on the roof say, I didn't get any free calculus. They're crazy. They already have a template made.